Hello, welcome back to the channel. So let's do one more example on definite integration. This is a different kind of problem. It's based on piecewise functions, but the approach is more or less exactly the same as we discussed in the last videos. You just have to sketch the graph of the function, and based on the given endpoints, you just have to calculate the area under the curve. So now let's start solving this question. And if you feel that it's sometimes difficult for you to sketch piecewise functions, I would suggest that in order to sketch piecewise functions, first draw all the functions that are given in the piecewise function format and then highlight the important areas that you need in the graph. So in this case, I would draw the sketches of y equals x and y equals 1 together on the same graph, and then at last I'll highlight the important areas that I need in the final graph. So let's start by sketching the graph of this function. So again, I have my y-axis, I have my x-axis, and I know that my y equals x is this, right? A straight line which passes through the origin and is also inclined at an angle of 45 degree to the x-axis. And now since I have the sketch of y equals x, let's also sketch the graph of y equals 1 on the same graph. So I know my y equals 1 would look like this, where this is 1, right? This point is 1. And now let's analyze the breakpoint. So I know that my function is changing at point x equals 1. So now let's denote that point on the graph. And I can clearly see that this is my x equals 1 point as well. Because since my graph is y equals x and the other graph is y equals 1, both of them intersect at x equals 1 only. So now I know where my x equals 1 point lies, so I can easily highlight the important areas in this piecewise function. And I know when my x is less than equal to 1, my function is fx equals x, which is this case. And it's only limited until x less than equal to 1, right? And after this, when my x values are greater than 1, I know that my piecewise function would become fx equals 1, which is represented by this line. So this was what I meant by highlighting the important areas of your piecewise function and then neglecting all the other unnecessary parts of your function. So this is the final curve of my function, right? So now let's discard the other areas that we don't need in this graph, which are this area and this area, right? And this is my final sketch of my piecewise function. When my x is less than equal to 1, my function follows y equals x, but when my x is greater than 1, my function follows y equals 1. And this is my x equals 1 case. And based on the question, let's check what we have to calculate. We have to calculate the area under the curve of this piecewise function based on the given endpoints from x equals 0 to x equals 3 in this case. So let's denote these points as well. This is my x equals 0, and let's suppose this is my x equals 3, and I want to calculate the area under the curve of this portion, which is represented or highlighted as follows, right? Because this would be the area under the curve of my piecewise function bounded by the endpoints x equals 0 to x equals 3. And now since I have to calculate the total area, it's pretty easy, right? I have a right angle triangle with base 1 and height 1, and I have a rectangle with base equals 2 and height equals 1. So let's calculate the total area, which would be the area of the triangle plus the area of the rectangle. The area of the triangle is half times base into height, and my base is 1, height is 1. The area of the rectangle is base into height, which is 2 times 1. My base is 2, height is 1. And with this, my total area becomes A equals half plus 2, which is 5 by 2 or 2.5. And this is my final answer. And this is equal to the definite integral of my function, of my piecewise function, bounded by the endpoints x equals 0 and x equals 3. So that's it for this video. I hope you found a different and an easier way to sketch piecewise functions. Please follow the channel in order to get notified about the other videos that I'll be uploading. Stay tuned. Thank you so much for watching. Bye bye.